Okay, so for those of you on the recording, I'm just talking about implicit functions. I just started class. Whenever we do implicit functions, we're going to get two equations. And honestly, the square with the y hints to me or tells me that I'm going to have two equations here. So I'm going to start by trying to get that y squared by itself. So let's divide by 4. So y squared either equals x over 4, or you can write it as 1/4 x. I usually like to write it as 1/4 x, but whatever makes you happy is fine by me. Both are correct. And then I'm going to square root both sides to get that y by itself. Y equals plus or minus radical 1/4 x. Now we're almost done. I think we talked about it in your class, but if not, I'm going to remind you. I always remind you to put the plus or minus in front of like the right-hand side square root, but someone, either your class or the other class, asked me, well, why don't I have a plus or minus in front of the y? If you had a plus or minus in front of the y, we would get all of the same answers as we did if we had a plus or minus in front of the square root. So like kind of a general rule of thumb we do in math is we just put it on one side and that will still give us all of the answers. So one of my answers is going to be y equals positive, and one will be what y equals negative. Now, before I write anything, we can simplify 1/4. We can do the square root of that. The square root of 1 is 1, and the square root of 4 is 2. I can't do anything with the x because there's only one x, so it's going to be 1/2 root x, and then the other one is negative 1/2 root x. Are we okay with that?
Do we have to write both, or can we just put plus or minus?
You can just put the plus or minus, but what I remember, at least personally, is that implicit functions is 2, and so sometimes physically writing 2 helps me. Good question, Hadley. All right, what next? My last class and I just spent a long time on these piecewise functions. Do you think that's a good place for us to go? Number 4? Okay, let's look at number 4. I'm going to copy and paste it down below. So the problem I'm seeing for just all my pre-calc kids in general with piecewise functions is I believe we did 2 examples where they like connected at 0. And so I think that you guys think that's the case all the time. But on these 2 examples, for instance, we don't connect at 0. So your graph looks a little different. So that's why I want to spend a little bit of time here. This is not a huge part of your test. So like if you're like, I'm just going to take the L on this, I'm never going to understand it, like that's personal choice, but it's also not that hard. So I want to talk about it in hopes to like make it seem a little bit more clear. Okay, so I'm just going to label some points on here to guide myself. And it looks like everything is happening at 1. So 1 is where things are going to change. I either want something less than or equal to 1, or I want something greater than 1. So I'm going to work on the less than or equal to 1. And so it says that y equals x when we are less than or equal to 1. X and x squared are both just parent functions. And as I think I just said earlier, you guys did really great on that parent function, that BFF graph test or quiz. I was really proud of you. So you know what a linear function looks like, right? You know it goes through 0, 0, and you know it's just like a straight line through it. Essentially, you're going up 1 over 1, but you can think of this as like a straight line all the way through. What I want to confirm, though, is that since 1 is where there's a change, you have to stop at 1. I put an open or closed circle on 1 because I get to include it, but then after that, I shouldn't have anything else on the other side of the graph. Sometimes it helps me to draw the entire parent function and then erase the parts that I don't want. So that's what I just did. I knew a linear graph goes through 0, 0, and then I just erased the part that's on the other side of 1. The common mistake I see is you know it's a linear function, so you're like, oh, I know it's a straight line, I know the slope is 1, 1, but you start it here, and then you go down this way. So like you guys have the general idea, but we can't just start our function like wherever our line of interest is. Like we have to start it where it actually starts, which is why it should start at that 0, 0. And so that means that technically it's ending at like the 0.11. And that'll be important in a second. Does anyone have questions on how I did that left side? Okay. The next one is my x squared. So now I have to graph y equals x squared over here. What a lot of us want to do is we want to start our x squared here, and you want to just square from there. Now we cannot do that. We have to do our x squared like normal. I have to do my x squared goes through the origin, and then it kind of curves up like that. I mean, it would also go on the other side. I just was too lazy to draw it, but I know that I don't want that side, and I don't want kind of what I drew right at the beginning. I only want it on this side of the 1 line, so I would technically erase this part of it. Oop, not that part. Because it goes through, because it's x squared, it's going to go through the 0.11 as well. If I were to plug 1 in for my x, 1 squared is what y is, and that means y would be 1 too. So this also goes through the 0.11, which is why I have them overlapping and connected at that point. Does anyone have any questions on that?
How do you want us to show that on the test if we don't have like different colors?
So you can just use your pencil and have it all in one color.
Right, but to show that it's like an open circle, does it have to be an open circle? No.
So since they both connect, technically you don't need to have an open circle there. I'm just trying to prove a point. When they are separate though, May, I do want to see one's a closed circle and one's an open circle. But these are at the same point, so technically you don't have to show the open circle.
Okay. And what is like the x squared if x, like how do you, I'm confused on that.
So x squared we know is a quadratic graph, right? It's going to be a and so I just want the parabola when x is greater than 1. So what I actually did is I drew a parabola and I just cut off the part that's less than 1.
Okay.
All right, should we do the other one? Okay, I see some nods. Oh, nope, that's not enough. Let's try this. Okay. All right, so the next one, now I have 3 parts here, and it seems like -2 is kind of where all the stuff is happening. So I'm gonna graph my line. And I'm gonna remember that -2 is where all the important stuff is happening. So I'm gonna make a mark on here for that. Okay. So we're good with that so far, right? Now we're going to address one problem at a time. So the first one is my absolute value of x. So I want to graph the absolute value of x when x is less than -2. What our first thought might be is to do our absolute value from -2, 0 from here. That is not what my parent graph looks like though. My parent graph always goes through 0, 0. So I have to think of it going through 0, 0 and then being my V shape off of that. Now, I drew more than we need, but I wanted to make sure that I ended up in the right place. So it looks like I would be, I think it's an open circle, and I would have my absolute value straight line going off this way. When I do this on like paper pencil, I just take a pencil and I draw everything and I just erase the parts I don't want. And that's what I'm trying to mimic with the iPad. We okay with the first graph? Okay. Let's move on to the next one. The next one says where x is equal to -2. Ooh, that's not an interval. That's only going to be at one specific point. Only at one point is x equal to -2. Essentially, this is the equation of a line, right? It's in the form y equals mx plus b. I'd be up at 1. I'd go up 1 over 1, etc., etc. But I only want the point, not the entire line. I just want the point where x is equal to -2. So you can do this one of two ways. One, you can graph x plus 1 and see where it intersects with my -2 line. So if you don't like that whole tile, I'll give you another option. So I'd go over here, I'd be like, okay, x plus 1 is a line. It goes through 1. I go up 1 over 1, up 1 over 1. Then I go down 1 over 1, down 1 over 1. Cool, it's a line. I don't need the whole line though. I only need this point right here on my axis so I can get rid of everything else. I only want it where it equals -2, not where it equals like -2 to -1. I only want it at one point where x is -2. Now, if you don't want to draw the line, you could figure out really easily what the y value is if x is -2. If x is -2, we'll just plug it in. So I'll do -2 plus 1. Well, that just equals -1. And by doing my line, that's exactly what I found. X was -2, so I jumped over 2, and then I went down 1. I only want that point, and I want it filled in because it's where it equals -2. You okay with that so far? Okay, don't be afraid to ask questions if you don't get it. We just spent a lot of time on this in my last class, so if you don't get it, it's not like you're the only one that doesn't get it. Okay, I am going to move on to do the x squared one though, so let me do the x squared graph. So this one, I'm doing x squared where x is greater than -2. So that means I need it to be a quadratic. I need it to be a parabola. I know that parabolas always go through 0, 0, so I'm going to hit it at 0, 0, and then I can just do my U shape around that. U shape. U shape. Now, what happens here is that it does not cross the open circle. The reason I know that is because if I were to do x squared of -2, if I was to square -2, I wouldn't get +2, I would get +4. So it should go as high as +4, and it should not ever hit my other open circle. Now, I don't necessarily need to see that it goes through 4, but I need to see that these are not the same point. Okay? Any questions? All right, if not, awesome. Should we look at something else?
Could we do number 2 with the asymptotes and the holes?
Yes, absolutely. So I was looking at this last period, and I'm not going to require you to do holes. So let's talk about asymptotes, vertical and horizontal, and I'm going to cut out holes because we actually will cover that in unit 1 or 2 or something in a while. So I forgot to mention that here with all this COVID stuff happening, and that's fine because we'll cover it another time. Is there any specific one you want to do, Quiva?
No, like any of them.
Does anybody else have a specific letter then that you're dying to see? Okay, cool. I'm going to start with an easy one. Letter C is pretty easy, so we'll start there. And then if anybody wants to speak up and wants me to do another one, I'd be happy to do that. Okay, so remember that vertical asymptote deals with the denominator. We're going to set the denominator equal to 0. Okay. We're setting the denominator equal to 0. If we have a problem with factoring, Hopefully that won't be something that you see on your test, but a lot of times factoring is probably the best way of doing this. So I'm going to do x squared minus 9 equals 0. So x squared minus 9 equals 0. You can either add 9 to both sides and then do your square root, or you can factor this. It's a difference of squares. X minus 3, x plus 3. X minus 3, x plus 3, and then so x equals two different numbers. It equals positive 3 and it equals negative 3. And those are my VA. So I'm gonna write that over here. VA is your x equals positive 3 and negative 3. Any questions on VA, vertical asymptotes?
So if there isn't a denominator, it's just none, or is it 0?
It's none. So like 3x plus 2, that's not even a reciprocal function, right? That's just a straight line. There's no asymptotes on that at all. Now, horizontal asymptote also deals with the fact that it's a fraction. So now we're looking at the exponents on top and on bottom. So again, if you get to like letter A, there's no fraction. So there's no horizontal asymptotes either. In our case for letter C, I have x squared and x squared. We look at the exponents first. So I've got square and square. Since those are the same, I now get to look at the coefficient. So the coefficients in this case are 1 and 1. So I can just make a fraction that's just 1 over 1. So my HA would be y equals 1. The other one that you are responsible for, the other horizontal asymptote, I guess, situation you're responsible for is if it's like letter B. On letter B, it's 1 over 3x plus 2. The exponent in the denominator is bigger than the one in the numerator. So the exponent on bottom is bigger, and anytime that happens, your asymptote is just y equals 0. I will not, for this test, give you one where the one on top is bigger than the one on bottom. Remember we did an example in class where we did log division? You are not responsible on that for this test. All right, any other questions on the vertical and horizontal asymptote part of this?
Can we do one that's not a fraction? Like A?
Yeah, so if it's not a fraction, there are no asymptotes. You would write none for both.
Okay, thank you.
Welcome. Sometimes I give you ones like that, not to trick you, but to like help you recognize what you're looking for. If to find the vertical asymptote, we have to set the denominator equal to 0, well, like letter A doesn't even have a denominator, so that's not possible. Kind of the same thing with the domain, like on number 1, letters B and F, those aren't fractions and they aren't radicals. So really the only problem with domain that we are dealing with right now is if it's a fraction or if it's a radical. And if it's neither of those, then your domain is fine. It's all real numbers. There's no problem. All right, what else can I answer or help with or do?
For like the 12 basic functions and stuff, are we gonna have to like do that whole thing again and like repeat all of them, or like what are we supposed to know about it?
So you just have to know name, equation, and graph. So like if I were to give you like a picture like that, you would have to know its absolute value and that it's y equals absolute value of x.
Are you gonna give like all of them?
No. There are so many other things for me to test you on. I just tested you on that on the last one. But like you need to know like if I give you a cubic one, what that is, or remember the difference between sine and cosine. You probably know all of them, but no, I will not ask you like increasing and decreasing, continuity, all of that stuff for all of those.
Will we have a question like that at all?
No, not even one. The biggest thing you need to know for basic functions is it helps you with your like the piecewise that we just did. So like if I say x squared, I expect you to know that it's a U shape, right? And then also for like number 9 right here where it says sketch, like you need to know that like this is going to be a V shape. You need to know that the next one is going to be a U shape. You need to know that sine is the waves.
So we're not gonna have to do like a number 7.
You will have to do number 7, but not with a BFF graph.
Okay.
Mhm. Should we do number 7? Yeah, let's do number 7.
Yeah.
Awesome. Okay, let's do number 7. So all we're doing is reading a graph. The only thing I really need you to know is like if I use words like domain, range, etc., like I just need you to know what those words mean. So if I'm looking at this graph, I got to do my domain. So my domain is my x's. I've got an arrow over here. It looks like it's covering everything, and I've got an arrow over here. I think my domain's fine. It's all real numbers, negative infinity to positive infinity. Okay, range is my y's. I have an arrow over here that points upwards, so that means I'm going to get all my y's forever up this way. Let's look down and see if there's a stopping point. I hit a low point here. Oh, and then my arrow goes straight, which means it's not going down anymore. So it looks like my lowest point is about, I guess I didn't give you any y values, so I would probably have to make it up. I would say maybe -4, maybe -3. Yeah, I'm put little dashes here, so I'd probably say -4, but depending on what dashes, it would be -3. So the smallest one is -4 and -3 to infinity. And I did put a key on mine. I have no idea what that key says. So if I like labeled it with like different dashes than that, that numbers might be a little bit off. So I'll look at that later and try and get it on the same page. But from here, I'd say 4. Extrema. So like I see some lows and highs. So the low I was just looking at is right here. And I just would list its coordinate point. 1, 2, 3, 4. 1, 2, 3, 4. So I have a min at 4, -4. And that's actually an absolute because nothing is lower than that. The other two I'm going to name are not absolute. I would argue they're local. I have a max right up here. I'd probably say that's at 1, 4.
How do you have a max if it continues to go up?
Good. It's just a local max, which means it's higher than the points around it. You see how it's a peak, but you know it's not the highest on the graph. All the extrema we were doing in parent functions, there was only one, and it was like the lowest of all of them or there were none at all. Since this graph has some highs and lows, anytime you have a peak or a valley, it's an extrema. But as you pointed out, this is not the highest point ever because it's going to keep going up forever that way, and we're going to have higher points. However, it is still higher than the ones around it, so we would classify it as a max.
So just out of the points that you gave us.
Yep, out of the points that I gave you. I would also classify this as a min, and this would not be not an absolute min because the other point's lower than it, but it's still a low point of the ones around it. So I would call this a min 1, 2, 3, 4, 5, like -5, -2. What I'm writing right now is absolute versus local. So most of what we have been dealing with, they're the same because there's only been one max or one min. In this case, there's been a couple, so I can label them. I do have an absolute minimum. I do not have an absolute maximum. The other two are just points of interest. They do go up, they do go down. All right.
On the test, are you if there's like local and whatever, like I don't know what the other one is, but are you gonna say like local for one and then like the other one too? Or are you just gonna say extremas and we have to say all of them?
If it was like this, I would say what's the local min or max and then what's an absolute min or max. It would be two separate lines, I guess.
Okay, thank you.
Welcome. Okay, I do want to finish this problem. I know that we have like a minute left in class, so if you are in a hurry and you need to leave, that's fine. But for those of you that can stick around, I will finish this problem. Also, for anybody who's like, I am not done studying, my F period went over a little bit, so I made them a Zoom link for 2:30. So if you do that, I can put that on your Schoology too, in case anyone wants to jump on there. Okay, for those of us still sticking around, symmetry, that's a pretty easy one. Is this symmetric or no? No, not symmetric. Or it would be symmetry and you would write none. All right, boundedness. Is this bounded above or below? Or none, or both sides?
Below.
Below, very good. This lowest max is a point of importance for us because it's bounded below. Nothing goes below that. So we'd say bounded below. Let's do zeros next because I think that's the easiest one. Where do we have zeros at? Basically anywhere we cross the axis, right? They're not on nice, easy points, are they? Well, that's unfortunate. This one looks like it's at like 2.5. And then this one, 1, 2, 3, maybe like 3.7 or something like that, negative 3.7. And then I'd say this one's at negative 5.5. I believe I'll give you like easy to read, like this is obviously at 5 or this is obviously at negative 2 or something. So don't let that deter you. Good, and then the last part is the increasing and decreasing. It looks overwhelming because this graph is bigger than ones that we've dealt with, but let's just take it one step at a time. Okay, so I'm gonna have a spot for decreasing and have a spot for increasing. As I start moving across the page, I start up here and then I'm going down. So I start by decreasing. Start from left to right, I'm decreasing as I go across the page. And that would be from negative infinity to this point right here, negative 5. So I'm decreasing from negative infinity to negative 5. Then it looks like I start increasing. So now I'm increasing from negative 5 all the way up to this point, which is negative 3. Are we okay with that so far? The next part is a straight across. That is what we would call constant. That's neither increasing or decreasing. So I could say constant, and I would just say the exact same thing I would say if it was increasing or decreasing. From what x to what x? In this case, it's negative 3 to negative 1. You guys have gotten really good at your increasing and decreasing. We're just taking bite-sized pieces at a time. Now, after I did that constant, now it looks like I'm increasing again. So now I'm increasing from negative 1 to positive 1. We can just U that onto our other increasing. So I'm just going to throw a little U and do negative 1 to positive 1. Then after that, it looks like I start decreasing again. Now I'm decreasing for a long time, from 1 until 4. So 1 to 4. Oops, sorry. And I'm just doing those weird circle things to remind myself that I'm going to the X point and I'm just finding what that X point is. So that's all those little weird circle things are. And then it looks like I've got 2 more, so we're almost done. Looks like I'm increasing from negative 4 to negative 5. Positive 4 to positive 5. What was that? increasing. And then it looks like I'm constant +5 to infinity. Okay. All right, any questions on that one? Okay. If you want to join after school, I'm going to go put a link for this on Schoology. If you want to Zoom later in the evening, if right now doesn't work, shoot me an email. And if you want to come in before school, I'll be in around 7 tomorrow morning. So I'm going to work to be there early for you guys. So I'm going to stop my share. If you need anything, stick around or join me in my next Zoom. And if not, have a good rest of your day. Good luck studying.